This video is for people who are new to CNC machines and wonder how a CNC program can do engraving, such as on this trumpet, or cut parts, such as this brass component, or make a robot write Boston Dynamics in blue chalk. A CNC program might look confusing, but it's just a list of simple instructions. The instructions have to be simple because machines cannot think. It only takes a few minutes to understand a CNC program, and then you'll be able to understand how all the computer-controlled machines work, regardless of whether they are sewing machines, laser cutters, or plasma torches. The driverless tractors also follow this concept, and so do robots. So let's create a simple CNC program. Let's assume that the customers of a skydiving business are frequently landing in the wrong area. As you can see, it's not easy to find the landing zone. So let's create a CNC program to make an Atlas robot use a lawnmower to cut a large X on the grass to make the landing zone easier to see, similar to how it is easy to see these designs from high up in the air. To begin, we must have some reference point from which to do our measurements. Let's assume that a surveyor placed an orange flag near the landing zone. From that reference point, the lower left corner of the X is 90 feet towards the east and 70 feet towards the north. And the upper right corner of the X is 80 feet further north and 50 feet further east. Although a robot could follow measurements using north, south, east, and west, CNC programs use an XY grid instead. Every location can be identified with an X and Y coordinate. So let's set the surveyor's flag to X0, Y0. The lower left corner of the X would have a coordinate of X90, Y70. The upper right of the X is at a grid location of X140, Y150. So now let's create a CNC program for the robot to cut that X. Most CNC programs today are using G and M code format, and most specify coordinates in inches or millimeters, but let's assume that the robot is using an XY grid in feet. The G code to specify inches is G20, and G21 specifies millimeters, but there is no G command to specify measurements in feet, so let's assume that G22 will do that. We would start the CNC program with G22. Next, we want to tell the robot to pick up a particular lawnmower from a storage area. Although there was no command for that either, when Boston Dynamics finally gets around to creating it, it will probably resemble the command that tells a CNC machine to pick up a particular tool. Specifically, M6 tells the machine to pick up a tool, and it is followed by a tool number, such as T7 for tool number 7. Therefore, a command to get a lawnmower might be something like M132 to pick up a lawnmower, followed by something such as L3 to specify lawnmower number 3 in the storage area. Next, we tell the robot to walk to the lower left corner of the X, which is at a grid location of X90, Y70. To tell a CNC machine to move to a particular XY coordinate, we use a G command. There are dozens of G commands to choose from, but the most common are G0 and G1. G0 means go to the XY coordinate as quickly as possible. So the third command in the CNC program would be a G0 command to go to X90, Y70. When the robot reaches that location, it will stop and read the next instruction. So we want the next instruction to be a command to turn on the lawnmower. The M3 command will turn on certain lasers, and M9 will turn on the water for some of the water jet machines. So let's assume Boston Dynamics creates M138 to turn on a lawnmower. That command would be the fourth instruction in the CNC program. Now that the lawnmower is turned on, we want the robot to move to the upper right corner, which is at a coordinate of x140, y150. But we want the robot to move slowly so that the lawnmower can cut properly. Therefore, we need to use a G1 command. That command tells a CNC machine to move to an XY coordinate at a specific rate. The rate is specified with an F command. It tells the machine how fast to move from one location to the next. Normally, the F command is specified in inches per minute or millimeters per minute, but let's assume that this robot wants the rate to be in miles per hour. Therefore, if the lawnmower can cut the grass at 1.5 miles per hour, then we would specify a feed rate of F1.5. When the robot has reached that XY coordinate, it will stop and do the next command. Therefore, we want the next command to turn off the lawnmower. Let's assume Boston Dynamics created M139 for that. Next, we want the robot to move quickly to X90, Y150, so we will use G0. We will then turn on the lawnmower with M138 and then use a G1 command to tell the robot to move to X140, Y70 at a rate of 1.5 miles per hour. Next, we add a command to turn off the lawnmower. The robot is finished, so we need a command that tells the robot to put the lawnmower back into its storage bin. Let's assume Boston Dynamics creates M133 for that. The CNC program is now complete. Those 11 lines of G&M code are enough to allow a robot to mow a big X in a grass field. If you can understand how that program works, then you can understand all of the CNC machines. Every CNC program is a simple list of instructions to move some type of tool from one XY location to another. And as the tool moves, various M commands turn on and off lasers or jets of water or switch to different colored threads. Some G commands are more complicated than the G0 and G1 command, but all of them are extremely simple. For example, G81 tells a machine to start drilling holes. In the case of drilling, the machine needs more than an XY coordinate of the hole. It also needs the Z value for the depth of the hole. If we set the top of a piece of metal to Z0 and we want to drill 0.85 inches deep, we must specify a Z value of negative 0.85. When the machine moves the drill to the next drilling location, it moves as rapidly as possible, and the R value specifies the Z coordinate to lift the drill before making those rapid moves. In this example, the R1.6 tells the machine to lift the drill to a Z value of 1.6 before making a rapid move to the next location. This will allow it to avoid hitting the clamp that is holding the part. The G81 command also has a feed rate that tells the machine how fast to drill into the material. In this example, the feed rate is 8 inches per minute. So, to drill 2 holes at different depths, you could use these 2 G81 commands, and you would add G80 afterwards to let the machine know that you are finished drilling.